The next talk will be Michele Bertoli. Hey, I can pronounce a few things. So the next talk will be about setState machine. One thing you should know is that, first of all, yes, Tracy did beat Ken Wheeler in a wrestling match yesterday. The winner got to be keynote. The loser had to go last today, so that's why Ken's going to be the last person to speak. And one thing about Michele is that he always complains about food. He's the worst Yelp reviewer of all. Everybody ready here? You good? All right. Please give a warm welcome to Michele.
Hello everyone. My name is Michele and I love React. I work in ads at Facebook and I build a product called the Creative Hub. What I learned in my career is that state management, especially when building UI, is pretty hard. As engineers, we have to keep track of the state changes over time, and we have to make sure that users can only perform a valid set of operations at any given point in time. And I was wondering if this complexity is intrinsic in building UI, there is nothing we can do about it, or actually, there are some solutions to it. And because maybe we use the wrong approach. And I'm going to show you an example, like the infinite scroll. I assume everyone has a rough idea how the infinite scroll works. And there are different ways you can solve this problem. I picked the simplest one, but what I want you to concentrate on is the approach that you are going to take, because there might be a problem on the approach. So if we were to building an infinite scroll component, the first thing we would do, we would attach an event handler to the scroll. Every time this scroll event fires, we would check whether the user scrolled more than 90% of the page. And if that's the case, we fetch more data and we append the new data at the end of the page. Like, so far, so good, I guess. So if we implemented this component, this would be the core functionality, right? We calculate the scroll percentage. If the scroll percentage is more than 90%, we fetch new data. However, this has a problem. In fact, we are going to, with this code, we would fetch more than expected, because the scroll event keeps on firing when we started fetching already. Again, there are different solutions. One of the most common is using a state flag. So we would set is fetching to true when we start fetching, and then when the scroll event fires, we check whether the user scrolled more than 90%, and also if we are not fetching already. And if we are fetching already, we just ignore the event. This is not a big issue, but now our component does two different things, something when it's fetching and something when it's not fetching. And the same applies to the render of this component. So you start adding a ternary, and you say if it's fetching, then you can show a loading indicator, a spinner, whatever, otherwise not. And again, but this works. The component has two states, it's fine. However, if we implement this and we try it, we soon figure out that when we reach the final page, we keep on fetching. So there is no way for us to stop fetching when there are no more pages. So if you suppose that your data returns an object that has more attribute, you can use this attribute to, for example, detach the event handler. So now you're doing three things: when it's not fetching, when it's fetching, and when there is no more data. And we forgot to think about errors. So if we want to deal with errors as well, here we go, has error flag. So we now have 4 flags. And if we think about a retry functionality, this is going to go on and on and on and on. And this can go even worse. This example is taken from the Redux repo, the async example. No blame on the author. I write code like this every day. But we use state flags here, like nested ternaries of state flags. So if the component is empty, we could either be fetching, and in that case we show a loading indicator, or it's actually empty. And if it's not empty, we show the post. You got the point, right? State flags are all over the place. And this approach, where you start solving a simple problem and then you find out all the edge cases and you add on top of it, is called the bottom-up approach. And the bottom-up approach is where you focus on linear transitions. As we said, it's going to A, B, C, like event handler, 90%, fetch more data. You very soon realize that you need context. So it's not just about, on this event, I'm going to perform this action. It's more like, on this event, if I'm not fetching, if there is no error, if I'm not retrying, then I'm going to fire this action. So you need context. And usually this bottom-up approach also generates code that is harder to understand. If you think about the nested ternary, it's not trivial to say what's going on there. And it's also complex to scale because, and maintain, because if you want to manage a new state, for example, is retrying, let's say, you have to make sure that you protect all the existing branches against this new state flag. And it's not trivial looking at all the state flags of a component saying what's going on, because state flags can be combined. So it's up to you to make sure that one is true, the other is false. But you can generate new states, new unpredictable states that obviously lead to bugs. So in the last 6 months, I spent most of my free time like playing around with state machines, because as the name implies, they should be a good way to manage the state, right? And since my friend Ellie told me that she didn't pay attention at her university class about state machines, I'm going to go through the basics, just one slide, just to make sure we are all on the same page. So the automata theory is studies these abstract machines and the problems that they can solve. They are able to recognize like finite languages, and they're used, for example, for regular expressions. And there are different types of state machines. There is, for example, the Turing machine, which is an infinite number of states. Hopefully, our user interfaces have a finite number of states. That's what we hope for. And it's also deterministic. So we are interested in the deterministic finite automata, which has a couple of interesting properties. It has one state at a time, so no more like is empty and is fetching at the same time. And also, given the current state and an input, is always going to give the next state, which is what we want to give to our users as well, hopefully. And the cool thing about state machine is you can define them using these 5 elements. So it's a pretty clean way to define a machine. So Q is the set of all the states that a machine can have. Sigma is the set of all the different inputs that the machine is going to accept. Delta is the function that, given a state and an input, is going to give you the next state. Q0 is the initial state, and F is the final state. And another cool thing about state machines is that you can use state transition diagrams to visually represent them. And this is a super simple state machine. You have A, which is the initial state, because it has this arrow with a circle. On the input alpha, it transitions to B. On the input beta, it transitions to C, which is the final state, because there's this double circle. And you may wonder, what does this have to do with UIs? So suppose we are building a user interface to configure Prettier. And Prettier, if you know what it is a super cool tool to format your code. And it has an option that allows you to enable and disable semicolons. And if you are designing the behavior of a button that toggles this option, you're going to have a state machine like this. So the initial state is semicolons. Then you toggle the button, and it goes into this no semicolon state. You toggle it again, and it goes back to semicolons. It would be pretty cool if we could define all of our user interface using these state transition diagrams, right? However, we can't, because as soon as we add a second option, for example, space or tabs, we're going to have to create one state for each one of the combinations of these options. So in this case, you would have 4 states. This is also the most controversial state machine ever created. We could argue like around this for years, because you can have semicolons and spaces, semicolons and tabs, no semicolons and tabs, and so on and so forth. So it doesn't scale. If you think about adding a third option, like for example, single quotes or double quotes, you're going to have 9 states, and the number of states is gonna explode. So That's where state charts come to rescue. And state charts is a visual formalism for complex systems. They've been defined in the 1987 by David Harrell in a paper. And it's basically an extension of the conventional formalism of state machines and state transition diagram, what we have seen before. Basically, it solves the problem that I just showed you. And I'm going to go through like the main features of this paper, like to show you what problems it's going to solve, and then we're going to see how we can implement this in code. Suppose you have this machine. So from A, it transitions to B on the input alpha, but both A and B go to C on the transition beta. So you have two arrows with the same input and the same destination. And these are just two, but you could have a transition diagram with like 1,000 of these arrows. You can create a compound state and just wrap A and B and say, no matter if you are in A or B, it's always going to go to C on beta. And this is going to solve an issue, like makes this chart like way cleaner. And you can also zoom out a bit and give this compound state a name. So D, for example. So you're saying D, from D on the input beta, it goes to C. And this is pretty cool because you can assume that every state has also a state machine inside. You can have nested state machines. The second feature is orthogonality, which allows you to have parallel state machines. So, for example, in this machine, you can have the state can be A and C at the same time. And these two machines, separated by a dotted line, can have their own state at the same time. So if you go back to the prettier example, you could have a machine for the semicolons, a machine for the space and tabs, another machine for the single and double quotes without having the number of states explode. Another feature is guards, which are basically conditions. So you're still going to have conditions, but you have conditions only on transition. So you don't have to check if the machine is in the state A or B, because the machine knows that. You can guard a transition with a condition. So for example, this machine is going to transition from A to B on the event, only if the guard is true. And the guard, you put the guard into the square brackets. Now, last concept is actions. Is the most important thing. It's mind-blowing. It's where it makes state charts a really great candidate for managing your state of your UIs. So an action is basically the output of the state chart. It's just a label that you put in your state chart. And when a transition happens, like this, the output of the state chart is this label of this action. And you put this action after this forward slash. So when this machine transitions from A to B on the event, the output is going to be action. You can have actions when you enter a state and when you exit a state as well. So when you enter the state A, the action is going to be action 1. And when you exit the state A, the action is going to be action 2 and 3. So basically, the workflow when you work with state charts is you send an event to the state chart. The state chart knows its state. It evaluates all the guards. It checks whether a transition needs to happen. And if it happens, it collects all the action exiting the current state, all the actions on transitions, all the actions on entering the new state, and it's going to give you a bunch of actions. And you have to do something about it. To quote Luca, which he wrote a great article on using state charts with Redux. Check it out. I met him on Twitter talking about state charts as well. He has this great analogy. He says, a state chart is a magic box. You tell it what happened, and it tells you what to do. But now I talked for like almost 20 minutes about theoretical stuff. You want to see some code, right? So let's do it. You first install xstate, yarn xstate. Xstate is an awesome library to design state machines and state charts with JavaScript. It's also functional and stateless. And we're going to build this machine, the pretty machine. So you start from the semicolon state. When you toggle it, you go to no semicolon state and back to semicolon state. And we have actions now. So when we enter the semicolon state, the action is going to be add semicolons. And when we exit when we enter the no semicolon state, the action is going to be remove semicolons. So now it should be clearer to you what actions are. Basically labels that describe what should happen when the machine enters that state. So we're just going to send the machine the toggle event, and the machine is going to give us, hey, you now should add semicolons, you now should remove semicolons. The first thing we need to do is to define this machine in a way that setState can understand it. And so you define it using this JSON object that you pass to the machine function, and we generate this pretty machine that has the initial state is semicolons, and then you define the different states. And each one of the states look like this. So the semicolon state on the toggle event, it goes to no semicolons, and the on-entry action is going to be add semicolons. Similarly, from no semi to semicolons, and the action is going to be remove semicolons. This format is pretty similar to the state chart XML, which is maintained by the W3C. Is that one is XML, this is JSON, but David, the author of setState, is working on a way to convert like one format to the other. But yeah, when we have this machine, this pretty machine, we can do this. We can do pretty machine.transition, given the semi-state and the toggle event, is going to give you back an object that represents the new state. And the new state is going to be no semicolons, and the output is going to have this actions property, which is the list of the action that you have to run. So if you are in the semicolon state, so semicolons are enabled, and you just toggle it, the action is going to be remove semicolon. So you have to do something about it. What should you do about it? Now I'm going to show you. And what about React as well? I built a library called React Automata. It's pretty simple, so you can play around with it or like build your own, which basically is a layer on top of setState that lets you manage your state within React using setState under the hood. It's an abstraction for state machines. And we're going to build something more like cool. For example, we're going to go back to the example of the infinite scroll. So you can see how the infinite scroll functionality looks like in a state chart. So you have the start state, which is your initial state, and the entry action is attach, because the first thing we want to do is attaching the event listener. When we are ready, we send the ready event to the machine. The machine is going to go in the fetching state. And the entry action is fetch, because the first thing we want to do is fetching the first page. If the fetching succeeds, we're going to go to the listening state. Only, you see there is a guard there, and there is the has more property that our API endpoint is going to return an object with this property has more, which we pass to the state chart that can evaluate. And it's going to transition to listening only if has more is true. If when we are listening, we keep on sending the scroll event, but you see, we have this condition. We're going to go in the fetching state only if the scroll percentage is greater than 90%. So we keep on sending scroll event, but the machine knows when it's time to actually transition to fetch again. And this loop is going to go through until you have pages. At some point, as more is going to be false, and you're going to transition to finish. And at that point, the entry action is going to be detached. So you have to detach the event handler. And if there is an error, you just go back to listening. So this is a state chart for an infinite scroll. How do you use it? First of all, you describe this state chart with setState, and you pass it as well as together with a component to the with state chart higher order component that React Automata provides. But let's see how it works. So we enter in the start state, and the entry action is going to be attached. So the question is, how do we do something? We want to react to this action that the state chart is going to give us. So you just define an action, a method, in the component that has the same name of the action. And React Automata is going to fire it at the right moment in time. The attach would look like this. For example, you use the reference to an element to attach the event handler. Okay, when the attach is done, so we are listening to the scroll event, we want to tell the machine that we're ready. We're ready to start fetching. And so how do we send a ready transition to the machine? We just use the transition function that we receive from the props, from the higher order component, with the label of the input that we want to give to the machine. Cool. So now something a little bit more complicated. When the ready event is done, the machine is going to transition to fetching. And the entry action is fetch. So we want to, first of all, react to it. And this is going to be an asynchronous function. So if we succeed, we want to tell the machine that we want to fire the success event. And if there is an error, we want to tell the machine that there is an error. And first of all, we have to add a method that has the same name of the action, just that, and React Automata is going to fire it at the right moment in time. The implementation of this fetch would be something like this. You extract the transition function from the props, and then you use this load data, which is like a function that loads the data from the APIs, returns a promise. When the promise succeeds, you pass the data together, you transition passing the event name and the data as well, because a cool thing about state charts is that you put the condition in the state chart, so it's the state chart that evaluates the condition. You don't have to do anything. You don't have to tell the state chart if there is more data. You just pass this data object and the state chart is gonna evaluate the condition for you. If there is an error, we transition to error. So the workflow when you use React Automata is even simpler, like it's one level above. So you just send transitions to the state chart with an event and some data. React Automata uses setState under the hood to calculate the current state, the next state, all the actions, and it fires all the action methods for you. You don't have to you don't have to think about that. The higher order component also accepts a second parameter, which is options. And if you set DevTools to true, then it's going to connect the state machine to the Redux DevTool extension. So you can have like super cool debugging functionalities like time travel, because it's pretty similar to Redux in a way, where you have the state and you have the events that mutate the state. It also gives you these action components, so you can say, I want to show these children of this component only when the fetch action happens. So it's basically a conditional that makes like things a little bit cleaner in your render method. Now, if you were here last year, I quoted myself saying that the best testing strategy is not writing tests. I'm going to quote myself again because I strongly believe in this. And I don't mean that you don't have your code base tested. I mean that whenever you can have tests for free, then you should go for it. And when I heard for the first time about state charts and state machine, I thought, hey, if we know all the states and all the transitions in advance, then tests could be automatically generated. And this was the test state chart method from React Automata does. You just pass a state chart and a component. You can also pass optional fixtures if you want to inject data. And this is going to calculate all the simple paths from the start state to all the other states, and it's going to move the component to all these states. And when the component is in each one of these states, it's going to take a snapshot. And a snapshot, if you don't know what it is, check it out. It's a super cool feature provided by Jest, which is a test framework for JavaScript. And it's basically the output of the render method, like serialized in a human-readable way. And so with this method, you're going to have a snapshot in each one of the states of the state chart for free. So for example, in the fetching state, this is going to be the snapshot, the loading indicator. In the error state, this is going to be the snapshot, something went wrong. And this is so you're going to have a bunch of snapshots for free, and I think this is pretty cool. So what are the benefits when you use state charts to manage your state? So the first one, you're going to have fewer bugs, and it's not me. I read a book about this, and by Ian Orox, and he made an experiment. He split a team into two, and one part of the team was using state chart to build the software application, and another part of the team wasn't. And the part of the software that was using state chart had 80% less bugs. It's easy to understand because you have this visual way to represent your state that you can even share with the rest of your team, not just the engineers. Like designers, for example, they're using already state charts when they design the user flow. And finally, you separate what happens, which are all the methods that you define in your component, with when it happens. When it happens is up to the state chart. So you define when things happen in the state chart, and you define what happens in your component. And they are also decoupled, because your component is just going to react to actions that the state chart is going to give. So you can easily change the states in the state charts and adding new states and new transitions, and your application still works. Max Stoiber, the creator of style components as well as Spectrum Chat, he knows how state charts work. He played around with React Automata as well, and he made a prediction. Everybody's going to use state machines for UIs. I'm doing my best here to have this prediction become true. If you want to see an example of this, I built this calculator at this nice URL here. Basically, a calculator seems a trivial application. I don't know if you ever built one, but it turns out it's not. And also, it's the kind of application where you need a lot of state flags. Because when a user enters a number, you want to know if they enter the number for the first operand, the second operand, or if the number that they enter is before or after the decimal point. And I built this calculator with no if statements, no state flags, only guards in the state chart. So go check it out if you are interested. Takeaways. Think about states more than transitions. If you use Redux, for example, you tend to think about actions. So you think about all the different actions that mutate your state. While with state charts, you think more about the different states that your component can have. You can call them modes, and then you just connect them with transitions. And this helps quite a lot. In fact, even though I'm not using state charts on a daily basis yet, I completely changed my approach, the approach I build components. And in fact, I'm using a top-down approach now, where I think about all the states, all the inputs, you know, set of states, set of inputs, set of transitions, and this is going to help me quite a lot. Obviously, a downside of it is that you're going to spend quite a lot of time thinking about how your components work before writing them, but then you can just switch your brain off when you write code. And you should do it only if you use state charts. And read more papers, because like papers that the truth, this one was from the 1987, and still it's very like it's a great candidate like to build your UIs and manage your state. So these are the reference to the paper, bit.li state charts-paper, and to the book that I mentioned. This book really inspired this talk as well. It's a great book. Go check it out. And finally, I just wanted to say thanks to Fede, which talked about state machines for the first time like almost 6 months ago, and he ruined my life, basically, because I spent all of my time on this. Thanks, Fede. David, which is the author of XState, and is also giving awesome talks about this topic as well. Ryan is the creator of React Router. He played around with XState and React for the first time, and I was really, really excited about that. Eric is writing documentation around state charts, so statecharts.github.io. Go check it out if you are interested. And thanks to every one of you to listen to me. I hope this was useful, inspiring. Please reach out to me later. I can talk about React and state charts for hours, even at the AP hour. I'm going to still talk about React. Thank you very much.